SAT Math Lesson 8 is part 2 of linear functions. So this is the heart of algebra, again, standard 3, 8, and 9. And this just goes through all the different scenarios of non-calculator based questions you might see relating to linear functions on the SAT. So let's look at these. They're very wordy, but if you read it very slowly and carefully and highlight key things, you should see they're not that bad. And they are questions we need to master in order to hit the benchmark. So first one, a landscaping company estimates the price of a job in dollars using this expression, 60 plus 12 times n times h, where n is the number of landscapers who will be working and h is the number of hours the job will take using n landscapers. Which of the following is the best interpretation of the number 12 in the expression? So when I look at the first one, it says the company charges $12 per hour for each landscaper, right? The next one, a minimum of 12 landscapers will work on each job. C, the price of every job increases by $12 every hour, and each landscaper works 12 hours a day. Well, just by knowing what n is the number of landscapers, right? And h is the total number of hours. So when it says a minimum of 12 landscapers, n represents the number of landscapers, so B cannot be the answer. The price of every job increases by $12 every hour. But remember, not only do you have to worry about, the number of hours, you also have to worry about the number of landscapers per hour. So that can't be it. And each landscaper works 12 hours a day. Well, H represents the number of hours, so that can't be it. So when I read it, the company charges $12 per hour for each landscaper. Letter A would be the choice. Okay, the second example. In the XY plane above, line L is parallel to line K. What is the value of P? What you have to know is parallel lines have equal slopes. I'm going to go through this one two ways. Number one, I know the rise over the run here from 0 to 2 means I went up 2, and then from -5 to 0 would be over 5. So if this has the same thing, right, the same slope, I know right away that if I go up 2, right 5, up 2, right 5, I went over 5 here, over 5 here, which would put me at 10 here. So P would equal 10, letter D. Now, another way to look at this problem would be to actually calculate the slope and algebraically find it. So right away, if I use the slope formula here, m equals 2 minus 0 over 0 minus -5, bling bling this, so I would get 2 over 5. So the slope of this line is 2/5, which means the slope of this line would have to be the same. So if I go and write the formula here, m equals -4 minus 0 over 0 minus p, what that ends up giving me is -4 minus 0 is -4 over 0 minus p is -p. Well, right now, this is hypothetically the slope. This is the slope of the top line. Therefore, if I take these slopes and set them equal to each other, now I could just cross multiply and get -2p equals -20, p equals 10, and that's how you find it algebraically. Example 3, right? So right away, in example 3, it says, which of the following is an equation of line L in the XY plane above? Well, guys, this should be very straightforward. Right away, you know it's a diagonal line. So this would be the equation of a vertical line. This would be the equation of a horizontal line. Those can't be it. So now the first thing I do is I find the slope. Rise over run, my slope is 1. So here, the slope is 1. Here, the slope is 1. Now I look at the y-intercept. Here, when I look, the y-intercept is at 0, 1. So when I write the equation, slope is 1x, and then my y-intercept is 1, so it would be plus 1, which is letter D. Number 4, in the air, the speed of sound S, right, in meters per second, right? So S represents the speed, right, in meters per second, is a linear function of the air temperature T. So T equals the temperature in degrees Celsius, and is given by the following function, right? Which of the following statements is the best interpretation of the number 331.4 in this context? Well, first off, when I look at it, identify this function's in kind of slope-intercept form, where the slope would be 0.6, the y-intercept would be 331.4. So identify the function and what 331.4 is in the function. And now read your answers. The speed of sound in meters per second at 0 degrees Celsius, right? At 0 degrees Celsius, if I interpret this, at 0 degrees, the speed is 331.4. That sounds pretty good right now. I'm just going to read the rest of the answers to make sure there's not a better choice. The speed of sound in meters per second at 0.6 degrees Celsius. Remember, 0.6 is how much the temperature goes up, right? So that is more slope related. The increase in speed of sound in meters per second, that corresponds to an increase of 1 degree. This kind of represents slope too, so that can't be it. The increase in speed of sound, remember, this is kind of like, this doesn't tell you how much it goes up or down. It's like the baseline. So right away, it can't be D. So letter A would be your choice. So when you look at this, on the next question, at a restaurant, N cups of tea are made by adding tea bags to hot water. If T equals N plus 1, how many additional tea bags are needed to make each additional cup of coffee? Well, if I write what my ordered pairs would be, N would represent my input, T would represent my output, where N represents the cups of tea, T represents the tea bags. Now, if you think about this logically, right, when I go to do my rate of change or my slope, right, that would be the number of tea bags, right, the change in tea bags over the number of cups of tea. So basically it would be tea bags per cup. If I look at that, if the slope of this line is 1, that means 1 tea bag per cup, right? Which means every cup you add, it goes up 1 tea bag, which would be letter B. Now, some people may make a table, right, and say 1 cup is 1 plus 2, which is 3 tea bags. 2 cups would be 2 plus 2, which is 4. And right away you'll see you went up 1 tea bag. All right. The next one. In the function above, b is a constant. If f of 6 equals 7, what is the value of f of negative 2? In order to evaluate f of negative 2, I first have to find b. Well, remember, this here is the same as y equals a number, right? So in this case, our input value x is 6. Our output value y is 7. So what we're going to do is plug that ordered pair in here. So if x is 6, right, we're going to replace f of x with the y value, which is 7, equals 3 over 2 times, we're going to replace x with 6 plus b. Now what I could do is solve for b. So 7 equals 3 halves times 6. Remember, it's no calculator, so multiply the numerators, multiply the denominators. 18 divided by 2 is 9 plus b. So when I subtract 9, b is equal to -2. But here's the thing. -2 is an answer, but they don't want, right? They don't want the value of b. They want us to evaluate f of -2. So now our new function becomes f of x equals 3 halves x minus 2. So I replace b with -2. So now f of -2 is equal to 3 halves times -2. So now that becomes my input, minus 2. And f of -2 is 3 halves times -2. It's going to give me 3 times -2 is -6. Divided by 2 is -3 minus 2, which gives me -5. Letter A. Okay. Which of the following equations represents a line that is parallel to the line with the equation y equals -3x plus 4? Remember, parallel lines have equal slopes. So what is the slope of the line given? -3. So now we have to find the slope of each of these lines. And remember, each of these lines are given in standard form. So it's much easier to find the slope of a line in standard form by taking the opposite of the number in front of x, which is a, and divide it by b. So right away, the slope of this line, what's the opposite of 6? -6 over 2 would give me -3. Right away, that ends up being the answer. But each of the other lines, that would be -3 over -1, which is 3. This would be opposite of 2 is -2 over -3, which is 2/3. This would be -1 over 3, which is -1/3. So A is the only answer. The next one, while preparing a run to run a marathon, Amelia created a training schedule in which the distance of her longest run every week increased by a constant amount. So right here, that phrase, right, is basically hinting to slope. If Amelia's training schedule requires that her longest run in week 4 is a distance of 8 miles, and the longest run in week 16 is 26 miles, which of the following describes how the distance Amelia runs changes between week 4 and week 6? So basically, we are looking for the slope or rate of change. So think of your ordered pairs here. Your input represents the week. Your output represents the number of miles. So if I write my ordered pairs, week 4, 8 miles. Week 16, 26 miles. So my slope or rate of change, 26 minus 8 over 16 minus 4 would give me 18 over 12. And if you divide this, it ends up being, or reduce it, it's 3 halves, or, so that what that becomes is 3 over 2 is 1.5. Our numerator represented miles per week. So right away when I read each of these, Amelia's increases the distance of her longest run 0.5 miles per week. Nope. She went up 1.5 miles a week, so that doesn't match up. She increases the distance of her longest run 2 miles each week. Nope. Increases the distance of her longest run by 2 miles every 3 weeks. That's tricky, but remember, your numerator is the number of miles, denominators is weeks. And Amelia increases the distance of her longest run by 1.5 miles each week. Letter D. The next one. This is a tricky one because it's no calculator. The table above shows shipping charges for an online retailer that sells sporting goods. There is a linear relationship between the shipping, right away you know it's a line, between shipping charge and the weight of the merchandise, which function can be found used to be blah blah. Which function can be used to determine the total shipping charge f of x in dollars for an order with merchandise weight of x pounds. So the first thing we want to do is find the slope. Now here's the thing. Working with these decimals will not be fun. So do me a favor. All of these round to about something. So I'm going to say this is about 17. This is about 22. This is about 32. And this is about 52. So what I'm going to do first is use these rounded up values to kind of get an idea of where it might land. So the first thing I'm going to do is find the slope here. So I have the ordered pair 5, 17, and 10, 22. So right away, my slope would be 22 minus 17 over. This is where I started, so now I'm going to do 10 minus 5. That means this would give me 5 over 5, or about a slope of 1. What answers can I eliminate just by that? My slope isn't even remotely close to 3.39, so C and D are gone. So now I have to determine between A and B because 0.99 is really close to 1. And if I didn't round, that's what I would get. So right away, I look. If I was to go back to 0, so backwards from 5 to 0, I would have to go down 5. And if I go down 5 from 17, that would put me at 12. So right away, what is my y-intercept? This function would be, f of x equals 1x plus approximately 12, which would be closest to letter B. Do not try to work with decimals there. Okay, the last few here. The line in the plane above represents the relationship between the height, h of x, right? So that's your output is height. And the base diameter x, so that's your base diameter is your x value, right? For cylindrical Doric columns in ancient Greek architecture. How much greater is the height of a Doric column that has a base diameter of 5? So a base diameter of 5 had a height of 35, right? Then a height of a Doric column that has a base diameter of 2. So base diameter 2 had a height of 14. So how much greater is the base diameter of 5? Well, 35 minus 14 would give you 21 feet. And the last one. Which of the following equations of the line in the xy plane above, right? Well, here's the thing. All of your answers, if you look, are in standard form. So what you can either do, right? One, I'll always start with slope-intercept form because that's the easiest. So the first thing I want to find is the slope. And then is the y-intercept easy to find? Yes. Right away, I know my slope is -1, right? I go down 1 over 1. So my slope is -1. My y-intercept is -4. So there's two things you can do here. Write your linear function, y equals your slope times x minus 4. Now, I could easily put this in standard form by moving the -1x over. So if I add 1x, I would get x plus y equals -4, which ends up being letter C. Now, say I didn't know that. Just by starting with the slope, I could use each of these equations to find the slope. This would have a slope of, remember, opposite of A over B. That would be +1. Nope. If that's +1, this is +1. This would be Negative 1 over 1, opposite of 1 over 1 is negative 1. So now we're down to these two. Now I'll just find the y-intercept. If I let x equal 0 here, 0, negative 4, this would have a y-intercept of 0, positive 4. Which one matches up? Letter C. That's two ways to approach that problem. Go ahead, check or try the assessment, and let us know if you have questions.